We will now look at the additional functions that are available. StarLab offers a range of functions that make it possible for us not only to get a reading, but also to perform various types of additional processing on the reading. Those functions are accessible by clicking on the Functions icon, and the Functions dialog window then opens up. As we mentioned previously, the range of functions that are available depend on the type of sensor being used. In this case, we're looking at a photodiode-based power sensor, and the functions that are available are appropriate to that sensor type. The averaging function allows us to smooth out the readings that are being displayed in situations where the power is unstable and the readings are jumpy and difficult to work with or record. When we open up that menu, we're offered a number of different possible time frames over which to carry out the averaging, and StarLab will display not the moment-to-moment power, but a running average of the power averaged over the selected time period. Offset allows us to eliminate a DC background level by setting the power level that's being measured in the background at that particular moment. That becomes the reference value, which will then be subtracted from all subsequent readings. We can deactivate that by moving the slide switch back to the original position. Scale factor. If we're measuring power after some attenuation, perhaps after a filter or a beam splitter, we can enter the attenuation value of that component into here, into the scale factor window, and StarLab will then display for us the calculated power before that attenuation. In many applications, this is useful. For example, if we have a beam coming out of a laser and passing through a number of optical components, we're accessing the beam perhaps after some beam splitter, but we want to display the power coming out of the laser itself. This is how we would do so. dBm is for those applications where we wish to display power in units of dBm rather than watts. For example, fiber optic telecom applications and similar. Normalize, in an application such as where we're measuring the power coming out of a laser, and then after a number of different stages in an optical setup, we could take a measurement, set that as our reference value, and then all subsequent measurements will be displayed as a unitless ratio relative to the reference value that was measured. Density. If we need to display not the total power in watts, but rather the power per unit area, for example, watts per square centimeter, we use the density function. We input to StarLab the dimensions of the beam. If it's rectangular, we're prompted to input 2 dimensions. If it's round, we're prompted to input the diameter. And then StarLab will take the power measurement and calculate for us the power density in units, in this case of microwatts per square centimeter. Again, deselecting that brings us back to an absolute power reading. Please feel free to visit the Ophir Photonics Group website for further information or to download the latest version of the StarLab application.